Now it's time to learn the geologic time scale. So for this part, you are definitely going to need to know the names of things in their proper orders. And they are sections of geology's calendar, if you will, that we call the eras and the periods. But let's go back to thinking about fossils for a second. Remember last time we talked about fossil succession and William Smith and how he used the regular ordered pattern of fossils to help him tell time. We now call these things zones, and a zone is any part of the rock that contains a particular fossil or group of fossils. So you can say, for instance, looking at that picture, fossil species E lived on planet Earth a certain length of time. It originated, it lived, and then it ultimately, the last one died off. It went extinct. And so that defines a unit of time. But then as soon as you take another species, the species D, for instance, you can talk about the time in which only species D lived, the time on planet Earth when both D and E existed, and then the time on planet Earth when D has gone extinct, but E continues. So see, just using two fossils like that, you can cut three little slices of time based upon the fossils that are there. Now, some fossils are better than others. Some we call index fossils, and these are characterized by those four things. I'd say just know that. I usually ask one question that says something to the effect of index fossils are best described as being A, B, C, D, and one of them I kind of make an answer that's wrong. Collectively, if we do this over and over and over again, we create this wonderful composite that we call the geologic time scale, which is geology's calendar. And it's going to look something like this. It's a series of names that indicate the fossils that we find within it. And since fossils have a time significance, it's like a calendar. Okay? Now this is analogous to a calendar in a couple ways. So if you look on the left side, I can talk about a bigger grouping, a decade, the 2000s. You can talk about a year within that 10-year group, the year 2001. Each year has 12 months, let's say the month of September, and then the second week, the 11th day, and that of course was the 9/11/2001. Big catastrophe for the United States. The geologic calendar is analogous in that we have big groupings and that go smaller and smaller and smaller, and they define times. And so we can say there are the eons, and there's the Phanerozoic, the eras and periods, epochs, ages, etc. And at the end, if you follow this all the way down, the age of the Maastrichtian, at the very end of that age, 65 million years ago, an asteroid hits planet Earth, kills dinosaurs, many other creatures, another event, a catastrophe. I put in red eras and periods because that's the currency that we're going to use in this class. And so these next few slides in this PowerPoint talk about the specific terms you need to know for an exam. So, Earth's geologic time scale, since life evolved on planet Earth in a big way with skeletons, has three different eras: the Cenozoic, the Mesozoic, and the Paleozoic. Now, one thing you need to know here is that they are stacked this way on purpose. Cenozoic at the top, Mesozoic, Paleozoic. In geology, for the time scale, just as with Steno's rocks, the oldest is at the bottom, and they get younger and younger as you go up. So the Paleozoic are these green things. Notice it's at the bottom. The Mesozoic is in the middle, and the Cenozoic is at the top. And that's the eras. Now those eras then are composed of different periods. It's just like saying the year 2020 has the following 12 months in it. The era of the Paleozoic has these periods in it. You need to know Cenozoic, Mesozoic, Paleozoic in the proper order from oldest to youngest. In the period column, you need to know 11 different words. Now, if you count all the words here, there are more than that here. But these are the ones, I'm going to tease them apart for you and tell you which ones to know. And after we do all the introductory conceptual material for the class, then we will start here at the bottom and kind of work our way up through there, talking about life and fossils and time all the way. So for the Cenozoic, you need to know the Paleogene and the Neogene. Paleogene is the bottom of the Cenozoic. Neogene is the upper part. And we live at the very top of this line. So these numbers over here, which I haven't talked about yet, these are in millions of years ago. You don't need to memorize these numbers, but just for now, just note that this top line, that's where we live. We live right here in the recent. The Mesozoic, the period or the era that most people really love, because this is the era of dinosaurs, consists of 3 periods: the Triassic, the Jurassic, and the Cretaceous, in that order. And then the Paleozoic consists of these 6 periods in this order: Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian. You do not need to memorize these terms, Pennsylvanian and Mississippian. They are local to the North America time units that aren't recognized internationally. So you just have 1, 2, 3, 4, 5, 6. Okay? The time scale is an example of relative time. If you ignore those numbers over there, and when they first set this up, no one knew these numbers, but these rock units are named by the fossils. So this is an example of relative time. The Permian is older than the Triassic. The Triassic is older than the Oligocene. The Oligocene is younger than the Ordovician, and so on and so forth. And just as you have memorized the calendar, January through December, in geology we use this calendar, and you will use it and memorize it at least for this class.